Hello everyone. Today I am going to discuss the fifth problem of AtCoder beginner contest 267, which is erasing vertices 2. So we are given an undirected graph of n vertices and m edges. So we can erase a vertex from the graph, and all the corresponding edges will get deleted, and the sum of all the corresponding neighboring nodes of the vertex will get added to the answer. So we have to delete all the n vertices in some order, and we have to print this value. So the cost of an entire in operation is the maximum of the costs of the individual operation. So what is the cost? So let's say this is a some graph. So when we are deleting one, the value of 2 and value of 3 will be the cost of the corresponding operation. So this is the cost of deleting vertex 1. So and we are deleting again vertex 2 and vertex 3, and at the end we are returning the maximum cost of all the operation. So the operation can be in the order of 1 2 3, like first deleting 1, then deleting 2, then deleting 3, or it could be 2 1 3 and so on, 3 factorial number of ways, and we have to the cost will be the minimum of all those. Okay. So you can check this line, and it is written here. So what will be our like n is 2 into 10 to the 5 years, so order of n or order of log n will be our desired time complexity of the solution. So what will be the answer approach, like the solution approach? So the first you can think is that, let's say we are given a graph G, and we are deleting a vertex v from the graph and all the corresponding neighbors. So sum of neighbors will get added, will be the cost. So cost of deleting v is the sum of neighbors. Okay. So let's say we are storing all the values of like the for deleting all the vertex. So let's say this is sum of I. Sum of I is deleting the vertex I from the graph. So let's calculate all the sum of I here. So let's take one sample graph, 1 2 3 4, and this is 5, and let's say that a of I is I. For now let's consider a of I as I. So what will be the value of a of 1? A of 1 will be 5, because 2 and 3 are neighbors of 1, and the value of 2 will be 4 plus 1, also 5, and this is also 5. This is 5 plus 3 8, and for 5 the value will be 4. So the sum will contain like all the values here. So sum will contain 5 5 5 8 and 4. So now the most optimal approach will be deleting the smallest value here. So why it is the most optimal approach, I will come it in a bit. So let's delete 4 from here. So this is an let's say this is an set. So we are deleting the smallest vertex from here. So when we are deleting 4 from the set, so when we are deleting 5 from the graph, so like the sum of 8 will get decreased. So sum of 8 is now sum of 4 is now 8. Now when we are deleting 5, sum of 4 will get decreased by 8 minus a of 5. So now a of 5 is 5 here, because it is a of I is I. So now sum of 8 will be sum of 4 will be 8 minus 5, which is 3. So now delete this, and it will be 3. So now what is the smallest vertex in all this? So now the smallest will be I think 3, which is the fourth vertex. So now delete this. Now after deleting this, so they will be deleted from the set. Now as 3 and 2 both are connected to 4, this will be decremented by 3 4, and this will also get decremented by 4. So now this will be 1 and this will be 1. So 5 and 4 will be replaced by 1 and 1. So now the most common the least value of the set is 1. So 1 will get deleted, and this will become 5 minus 1. Now again 1 will get deleted, and this will also become 5 minus 1 minus 1 3. So at the end 3. So what will be our maximum value? Our maximum value is 4 here. So answer will be 4. So this is our solution approach. Now let's come why selecting the minimum value from the set is optimal. That will be obviously your question, why we are selecting the minimum value from the set every time. Because if we define the algorithm that we are selecting the minimum value from the set every time, then the algorithm becomes quite easy. We are only just deleting all the values from the neighbors of the current vertex which is getting deleted from the set, and again adding their sum to the set. So now let's prove why it is optimal. Now, so one thing I forgot to mention here is that when we are deleting any element from the set, we'll just take maximum of answer comma that element. So maximum of answer comma is dot begin, you can say, or the first element of the set, that is say is 0. So this is our desired function. So when we are deleting something from the set, we are taking the maximum answer from that element. So now let's say this is the set, and s1 is less than s2, s2 is less than equals to, and less than equals to, less than equals to. Okay. So this is the 5 set element. Now you are arguing is that the first deleting the first element is not always optimal. So let's consider we are deleting the third element from here. So s3 will get deleted. Now S3, when we are deleting S3, we are impacting S2, S4 and S5. This is the most optimal case, that when we are deleting S3, we are impacting all these three. And we are taking maximum of answer, comma S3 here. Maximum of answer, comma S3. Okay, got it? Now, let's say after deleting these three, S2, S4 and S5, let's say S2 becomes the minimum value of the graph now. Let's say the most optimal case. Now the set becomes S2, S4, S5 and S1. So obviously S2 will get decremented by the value of 3. So let's say S2 minus V3, S4 minus V3, S5 minus V3. This is the most optimal case. So I can prove you is that we can always come to this after deleting s1 also. Now s1 is less than equal to s3. So when we are deleting s1, after deleting s1 we may not impact any of the other four values. This is the most optimal case for your argument. So now when we are deleting s1, we may not change other values. So let's delete s1. It is an independent operation. So after deleting s1, it is not impacting our answer. If your argument is also true, our maximum value of answer will be s3. Now as s1 is less than s3, this operation, the first operation, will always benefit us, because now the value of answer is s1, and in the next operation you can delete s3. So it is always optimal to choose s1 before s3. I hope you got my explanation. If you still have any doubt, you can ask me or you can argue me in the comment section. Now let's jump into my code. So this is my code. So what I am doing is I am taking the value of sum of x and sum of y. When we are taking input, let's say x and y, there is an age between x and y. So we are both incrementing the value of sum of x by by and sum of y by b of x. And we are always deleting the first element from the set, and we are just decrementing the value of all the neighbors of x. Okay. And again, if the value is present in the set, the sum of j is present in the set, we are deleting from the set, and at the end, after changing the value of sum of j, we are inserting it again in the set. And at every step we are taking answer equals to maximum of answer comma w. What is the w is the sum of is like the s0 here, obviously. So s0 is the sum, we are taking maximum of answer comma s0 always. So if you are using 1 base indexing, it will be s1, or if you are using 0 base indexing, it will be s0. And at the end we are printing answer. So bi, what bi here, bi is nothing but I am calculating, taking b is our ai array here initially, and I am also using this b for visited array. So when some index is visited, I am marking it as 0. So if the neighbor is already visited, we will just continue, else we will do these operations. I hope you got my solution and explanation. If you still have any doubt regarding the explanation or regarding the solution, I will post the solution in the description box also. Always ask me in the comment section. I will reply to the comment or reply to the doubt. Please like the video and subscribe to my channel. Thank you.